Hi guys, welcome back to another video. Today's sorting technique is insertion sort. Insertion sort is a simple sorting algorithm that works similar to the way we sort playing cards. As we have already seen in our previous two videos, that is, in case of selection sort, the smallest element is shifted at the front of the array, whereas in case of bubble sort, the largest element is shifted at the back of the array. In case of insertion sort, the array is split into a sorted and an unsorted part. Values from the unsorted part are picked and then inserted at the correct position in the sorted part. Let's consider an example of an array A of size 6 whose contents are 965082. The approach which we use to sort this array is that we traverse the array from I is equal to 1 to 5 and then we check whether the left part of the array is already sorted. If not, then we insert the ith character at the correct position in the sorted part. Initially the value of I is 0 and the value of key is A of I, which is 6. Then we initialize j as I minus 1 and then we traverse j from I minus 1 to 0. So the initial value of j is 0. Then we check whether j is greater than or equal to 0 and the value of j is greater than key. Since here the value 9 is greater than 6, therefore we update the value a of j plus 1 to a of j, that is a of 1 now becomes 9 and then we decrement j. Again we check whether j is greater than or equal to 0. Since the value of j is now negative, therefore we end the while loop and then update the value of a of j plus 1 as key. So the new value of a of 0 is 6. Now we again increment the value I. Now here we can see that the value a of 0 and a of 1 is already sorted. That is, the value preceding to the second memory location are already sorted. So now I points to the third memory location or the value 5 and the new value of key is 5. Now we initialize j to I minus 1 which points to 9 and we check whether j is greater than or equal to 0 since it is, and the value a of j is also greater than key. Therefore, we update the value of a of j plus 1, that is a of 2 as 9 and then decrement j. Again we check whether j is greater than 0 and the value of j is greater than key. Since 6 is greater than 5, therefore we update a of j plus 1, that is a of 1 as 6 and then decrement j. Since now j is not greater than 0, therefore we simply come out of the while loop and update the value of a of j plus 1, that is a of 0 as key, which is 5. Now we increment I. As we can observe that the values preceding to the I are already sorted, which are 5, 6 and 9. Now again we initialize the value of key as 0 and j as I minus 1, which points to the third memory location or the value 9. Now since j is greater than or equal to 0 and the value of j is greater than key, therefore we update a of j plus 1, that is a of 3 as 9 and decrement j. Again the value of j is greater than 0 and 6 is greater than the value of key, which is 0. So again we update the value of a of j plus 1, which is a of 2 as 6 and decrement j. Again we perform the same steps, that is we update the value of a of 1 as 5 and decrement j. Since now the value of j is less than 0, therefore we simply come out of the while loop and update the value of a of j plus 1, that is the value of a of 0 as 0 and then again increment the value of I. The values preceding to the value of I are already sorted, which are 0, 5, 6, 9. Now the new value of key is 8 and j points to I minus 1, that is 3. Since the value of j is greater than 0 and the value a of j, that is 9, is greater than key, therefore we update the value of a of j plus 1, that is a of 4 as 9 and then decrement j. Now we can see that j is greater than 0, but the value a of j, which is 6, is not greater than key. Therefore, we exit the while loop and update the value of a of j plus 1 as 8. That is, the value 8 is inserted at the correct position. Then we increment the value of I. So the new value of key is 2 and j points to the fourth location, that is I minus 1. Now since j is greater than 0 as well as a of j is greater than key, therefore we update the value of a of phi as 9 and decrement j. Since j is greater than 0 and the value a of 3 is greater than that of key, therefore again we update the value of a of 4 as 8 and decrement. We keep on decrementing until we reach a condition where j is greater than 0 but the value of a of j is not greater than key, that is 0 is not greater than 2. Therefore, we update the value of a of j plus 1, that is a of 1 as 2. So now 2 is inserted at the correct position. Now we exit the while loop and then we also exit a for loop. So finally we are with a resultant array whose contents are 2, 4, 5, 6, 8, 9. So the space complexity of this algorithm is order of 1 since it does not use any extra array. The time complexity of this algorithm is order of n square. Let's begin with the code. Initially we declare a variable n, which is the size of the array, and then input n. Next we declare an array of size n and then input the array elements. Next we call a insertion sort function, which is not yet created. We will create it later. The arguments to the function are the array and size of the array. Now we print a sorted array. Now we can create a insertion sort function. As we have seen in the explanation part, we first traverse the array from I is equal to 1 to n. And then we assign the value of key as a of I and initialize j as I minus 1. Then we again insert a while loop for j is greater than or equal to 0 and the value of a of j is greater than key. If the following conditions hold true, then we update the value of a of j plus 1 as a of j and then decrement j. And finally, after the while loop, we update the value of a of j plus 1 as key. So we are done with the code and now we can proceed further and run the code. Let's insert our array size as 6 and the array elements as 965082. So assorted contents are 0 to 5, 6, 8, 9. If you found the video helpful, then hit that like button and subscribe to my YouTube channel for more such upcoming videos. Thank you.